For loop is one of the most important loop. After for, expression 1 semicolon, expression 2 semicolon and expression 3 are written. Expression 1 is the starting statement. Expression 2 is always some condition to be tested. Until the condition is true, the loop executes. Whenever the condition becomes false, the loop stops. Expression 3 is update statement where the variable is incremented or decremented for the loop. Within the curly brackets, the loop statements are written. If the statement is single, then curly brackets are not required. The example is for I is equal to 0 means initial value of I is 0. I less than 10, so I will change from 0 to 9, I plus plus. So every time I will be incremented by 1. Here, if we write I equal to I plus 2, then I will be incremented by 2. So in whatever way we can increment or decrement also. Any of these statements logically can be not written if you want, but the 2 semicolons are required. That is a compulsory condition. For loop with only 2 semicolons becomes an infinite loop, and then that loop will be broken using break or exit type statements. Now let's go to our compiler and run something. So the basic program is print say 10 numbers. So integer n, and we want to print 10 numbers. So for n is equal to 0, that is starting condition, n less than equal to 10, that is the test condition, and n plus plus, n will be incremented by 1 every time when loop executes. Now here the loop curly bracket will start and we have to write down the statement to print. So printf and we have to print n, so n and semicolon. This is a single instruction, so we can remove curly bracket. So here n number is defined as an integer. It will start from 0 to 10 and every time the number will be printed. So let's run this program. 0, 1, 2, 3, 4, 5, 6, 7. Now we can put here \n, so they will be printed vertically. It is not necessary that every time number should go from low to high value. It could be opposite also. You can write this type of statement. N is initially 10, then it will be, condition will be greater than 0 until n is greater than 0, and now here n is minus minus. So what happens is, initially n is 10, it will go on decrementing every time until 0. So numbers from 10 to 1 will be displayed here. Let's see this, 10 to 1. So as per our requirement, we can change this starting and test condition, also increment decrement. Once you know this, you can write down all the programs we did in do while and while loop, that is sum of the numbers, average, factorial, then reverse, palindrome, and Fibonacci sequence, different patterns of stars or something. All of them you can try and do try them. We'll here write some other programs. So first we know that in first standard we study the tables of 1 to 10. So let us draw the tables of 1 to 10. So say integer I, comma j, suppose the two integers we define. So this is the programs is for tables. We have to write down the tables as the table of 1 is 1, 2, 3, 4, 5, 6, 7. Table of 2 is 2, 2 1s are 2, 2 2s are 4, like this. Then 3 1s are 3, 3 2s are 6, up to 10's table, 10, 20, 30, all tables we have to write. So the number I in the horizontal way will change from 1 to 10. The number j may be vertically changed from 1 to 10, and we have to draw the complete table of the numbers from 1 to 10. So for I is equal to 1, that is starting value, I less than equal to 10, that is the test and end value, I plus plus. So I will change from 1 to 10. Now for loop starts. I will change from 1 to 10. For 1, how the table is generated? 1 1s are 1, 1 2s are 2, 1 3s are 3. So j will have the value from 1 to 10, so that the table of 1 will be generated. So for this tab is not necessary. It is just for good looking or convenient object. J is equal to 0. J again less than or equal to 10, because we want the tables up to 10. And j is also plus plus. So j will increment. So j is 1 initially. So initially I is 1, j is 1. Next is I is 1, but j will be 2. I is 1, j will be 3. So j will go on changing from 1 to 10. So the table of 1 will be generated. Then I will become 2 and j will change from 2 to 10. So table of 2 will be generated. So in this way the tables will be generated. And every time the value of result is multiplication of I and j. So printf %d, and what we have to multiply is, what we have to display is I star j will be displayed. Now here we'll have some space so that the numbers will not be very near to each other. That's why I keep one space. So I star j will generate the table of 1, then table of 2, then table of 3. The table of 1 will be written horizontally. Now table of 2 will be written on the second line. So here we have to write down that go for the next line. How do we go to next line? Printf percent, percent is not necessary, only go to next line, that's all. Now look at the loop. There are two loops, there are two for loops. This is outer for loop. Outer for loop is ending here. Let us end outer for loop here. So outer for loop is having the number I, that is from this point to this point. This is inner for loop. For the inner for loop, there is a single statement to be executed, so curly brackets are not written. And this print statement is a part of I's for loop and not of J's for loop. Okay, let's run this program. 1 2 3 4. Actually the tables are printed, but the look is not good. So we have to adjust the formatting. The numbers here are changing in 2 digits. The maximum number is up to 3 digits. So let's write here up to 3 digits. Now good looking tables are generated. This type of for loops are called as nested for loop, that is for loop within a for loop. It's called as nested for loops. Okay. Now let's try something else. We'll find out now divisors. Let's find out divisors of a number. So user will enter any number and will have to provide all the divisors. We know that for any number, the two divisors are fixed, 1 and the number itself. So it is no point in finding out those divisors. So you will find out other divisors, if any, for any number. So let us find out the divisors for number n. So this n number will be given by the user. So let's ask the user, give indication to user that enter the number to find divisors. Enter number to find divisors. So user will enter number. We have to read this number. So scanf %d, comma, ampersand n. So this is the number of which the divisors are to find out. Now, for any number n, how many divisors could be there, or how to find the divisors? Divisors could be any of any number, and we have to check from 2 onwards because 1 is always the divisor. From 2 onwards, how many numbers we have to check? Up to n minus 1, we may think that anything could be divided. But if you think more, you will understand that up to n by 2 only, the divisors could be there. Because if n is divided by 2, then up to n by 2 will be the maximum divisor. So let's check the divisors from 2 to n by 2. For this, we need a counter, sort of variable. Let us call it as I. So check whether any number from 2 to n by 2 is a divisor of n. So for I is equal to 2, that is the starting number, I less than or equal to n by 2 is the end condition, and I will be increment. So all the values from 2 to n by 2 will be checked here. For example, if I is equal to 20, then 20 by 2 is 10. So from 2 to 10, all values will be checked whether they are divisor of n or not. Now how to check for divisor? If any number is divisor of n, then when you divide the number, divide n by that number, then remainder will be 0. So if n divided by n remainders, for remainder we need percent. N percent I is equal to 0 means the number is divisor. So here we get that it is a divisor. So if this condition is satisfied, then printf %d I is the divisor, and we have to keep some space between the divisors, or maybe backslash n, so we get the divisor on the next line, empty divisor on the next line. Now for loop, this for loop starts here. There is more than one statements in the for loop, so we need curly bracket. So in the for loop there are 2 statements. Continuously I will change from 2 to n by 2, 1 by 1. Every time n will be divided by I. If remainder is equal to 0, then the number will be printed. If remainder is not 0, then if statements, this part will not be executed and the next iteration of for loop will start. Now let's run this program. Enter the number to find divisors. I just entered 20. So 2, 4, 5, 10. Very good. 1 and 20 are already there. So these are the divisors. So rerun the program. Suppose I write here 100. So all these are divisors. So all the divisors are given. Very good. So rerun the program. I take suppose 360. I give some number. 2, 3, 4, 5, 6, 8, let's give tab here because more than 15 they are there. So when there are many, then we must give some tab or something, /t suppose. Run the program. 360 suppose, many devices. So all the devices are displayed here. Because there is a limitation of the screen, so we have got all the devices. Now let's try something else. Let us try to find out largest of 10 numbers. So we have to get the 10 numbers. The 10 numbers will be entered by user. So user will enter 10 numbers. So let us say int x, where x is entered by user. We want to check 10 numbers, so we need a counter for 10 numbers. So let I be the counter. And we have to find largest. So largest is one of the variable. Variable name could be anything. As far as possible, give the variable name which is having some meaning if possible. So we have defined here. Now give indication to user that enter the numbers. Suppose enter, let us do it for 5 numbers. Enter 5 numbers. We can take it for any numbers. Enter 5 numbers. Now we have to read these numbers and find out largest. Whenever there are large number of numbers, immediately we cannot find out largest. So we have to do the actually comparison. So at a time only 2 numbers can be compared. So let us consider that first number, initially consider first number is largest and second number is next. So compare the largest and next. If the first itself is largest, then keep it as it is. But if second is the largest, then replace the largest to second number. Then this largest will be compared to third number and same procedure. This largest will be compared to fourth number and same procedure. So whenever there are 5 numbers, first will be considered as largest and there will be 4 comparisons. So first take the first number and consider it as largest. So scanf %d and consider the first number itself is initial largest. Now this largest we have got. Now we have to get 4 more numbers. So for I is equal to 1 to I less than equal to 4 I plus plus, because we need 4 iterations of this. And here the for loop starts. In this loop we will get the number and call that number as x because it is the incoming number and which we have to compare. So scanf %d and x. Here also we have to give this symbol of ampersand, otherwise it will give us error. So out of 5 values, the first is largest and other 4 will be eventually x value. Now we have got the x value as the next value and largest is already we have. So let us compare. If largest is greater than x, that is the desired condition. We don't have to do anything. And if largest is less than x, then we have to change it. So if largest is less than x, that means x is bigger. Under this condition, consider largest is equal to x. So replace the largest by x value if x is bigger. If x is smaller, then keep the largest as it is. So largest variable will get the value of x only if the initial largest is less than x. Now this procedure will continue for all the 4 numbers. So for loop will end here by taking 4 numbers. Once the for loop ends, we have to end this also. Once the for loop ends, then we get whatever is in largest is the actual largest value. So printf largest is %d, and our variable name is also largest. So largest will be printed. Let's check this for syntax and run the program. Enter 5 numbers. Now I just enter any random numbers. Largest is 84. Yes, it is giving the largest correct. Now this is looking not good. So here we'll have \n, so it will look good next time. Run the program again. Enter 5 numbers. So I just give 85, 123, 65, some minus number, minus 234 suppose. Then 64, largest is 120. So in this way we get largest. If we want smallest, then only consider the first number as smallest, and the condition will be exactly opposite here. If smallest is greater than x, then we get this. Now let us give choice to user that to find out largest among how many numbers. So suppose user wants to find out among n numbers, then let's give this choice to user, n. So printf largest how many numbers to find largest. How many numbers to find largest? That is given first. You can give question mark also. Now we have to read this n value. So scanf ampersand n. Now user will enter some number 5, 6, 7, 10, 20, 50, whatever number of numbers user wants to enter, and that is n. Now user has to enter these values. We have to do this, and what change will be here is we have to go here from 1 to n minus 1, because for the first number we are considering largest and remaining n minus number we are comparing. So let us run this program. Run. How many numbers to find largest? Suppose I want to find the largest among 7 numbers. Now I will have to enter 7 numbers to find out largest. So I will enter some numbers 8, 45, 23, 100, 37, 98, 1, 2, 3, 4, 5, 6, 7. I have entered. No, one more number. 25. Largest is 100. So in this way, the largest is. So you can write a combined program that enter the numbers in numbers and find largest and smallest both. Do try this, and also try all the programs we did with do while and as well as while loop using for loop.